In this video, we will be talking about two important concepts with regard to confidence intervals: accuracy of confidence intervals and precision of them. Well, what is the difference between them? We'll be getting into the details of that. Accuracy of a confidence interval really depends on the alpha, right? If you want to increase the accuracy of your confidence interval, you reduce the alpha. Basically, going from alpha of 0.05 to alpha of 0.01, you're increasing the accuracy of the confidence interval. Basically, you're going from 95% confidence interval to 99% confidence interval. Has a smaller alpha, which means the probability of type 1 error is smaller. You're increasing the accuracy. But precision of a confidence interval depends on a metric that is called half-width. And half-width is essentially half of the width of the confidence interval. Upper confidence limit minus lower confidence limit divided by 2 is the half-width, or the width of confidence interval. To better explain this, I want to go back to a previous example that we had, example 8.1. And here in this example, we constructed two confidence intervals. In part A, we constructed a 95% two-sided confidence interval. In part B, we constructed a 99% confidence interval. And what happened is, basically from part A to part B, we increased the accuracy. Basically, 99% confidence interval is more accurate because it has less or smaller alpha, probability of type 1 error. But what else happened going from part A to B, from this confidence interval to this confidence interval? The 99% confidence interval is wider than 95% confidence interval. You can see that. This is smaller and this is larger. So it's a wider range. It's a wider interval. So it is less precise though, because the width of the interval is more. So the 99% confidence interval is more accurate, but less precise. It is more accurate because it has a smaller alpha. Alpha is 0.01, but is less precise because the width of 99% confidence interval is more than the width of 95% confidence interval, and you can see that here. So to measure precision, we use half-width, which is half of the width. Basically, for two-sided confidence interval, this is the half-width. For one-sided confidence interval, this is the half-width. And for accuracy, we basically look at alpha. Now, how do we control these two factors, accuracy and precision? Because these two factors are very important when you're constructing a confidence interval. Well, to control accuracy, we basically specify our alpha. You make a decision on whether you're going to construct a 95% confidence interval or 99% confidence interval. And that's basically controlling the accuracy right there. But how do we control the precision? Well, we control the precision by specifying a half-width. So let's say that you're calculating confidence interval, or let's say 95% confidence interval on average age of patients in a hospital, and you can specify your half-width, basically saying that I want to have a confidence interval, 95% confidence interval, with a half-width of 1.5 years, right? So that's specifying the precision that you want. That means you essentially want a confidence interval that has the width of 3, or half width of 1.5. half width is U minus L divided by 2. So how do we satisfy that? How do we essentially design this process so we will end up with a half width of 1.5 years? The way that we satisfy that is by choosing an appropriate sample size. By choosing an appropriate sample size, you can get to a half width that you desire. And spoiler alert, as you increase your sample size, your half width goes down, which is a good thing. But increasing the sample size is costly, time consuming, sometimes needs more effort and cost. So how do we choose your sample size? Here you're looking at choosing a sample size for a two-sided test versus choosing the sample size for a one-sided test. And the most important thing here is it has this half width in it. So based on a half width that you want, by this formula you can calculate what sample size would give you that half width. And if these two formulas give you any number of decimal places, let's say 12.53, you should always round that up to 13. So you make sure that you 100% going to achieve that half width. Because if you round down, you're not going to achieve that half width. So let's take a look at one example here. Here we're looking at this example that says, given that the standard deviation is 0.5 and the original parameter of this test n was 25, alpha 0.05, and this is a two-sided hypothesis test, as you can see. If we wish to construct a two-sided 95% confidence interval on the mu that has a half width of 0.1, how many students should we survey? And this example is about the GPA of students in the university and whether the average GPA is 3.0 or not. And we want to construct a two-sided confidence interval. And the key constraint that we have here is we want to have a half width of 0.1. What does that mean? That means the confidence interval that you want to have at the end should bracket with an L and U that is only 0.2 apart from each other, because the half width is 0.1. That is 0.2. It has the width of 0.2. I don't know, maybe giving me something like 2.9 and 3.1, maybe. That confidence interval has a half width of 0.1. But we don't know if that's going to be the actual confidence interval. So what we want to just calculate here is how many students should we survey so we can guarantee that our two-sided confidence interval has a half width of 0.1. Well, here we have a two-sided, so this is the formula that we're going to use. Part A, n is equal to z of alpha over 2 sigma over half width squared. So that is z of 0.025, because this is 1 minus alpha, so alpha is 0.05, times 0.5, that's sigma, divided by half width, which is what we want, 0.1 squared. And if you calculate that, that is 96.04. And as I mentioned, you should always round this up to 97. So basically, if you survey 97 students and calculate their confidence interval based on 97 students, you will end up with a confidence interval that has a half-width of 0.1. Now in part B, it says, if we want to construct a 95% upper confidence interval, so basically we're just calculating the U on the mu that has a half-width of 0.1, how many students should we survey? So for one-sided, this is the formula, and the only difference is z of alpha over 2 is going to be z of alpha sigma over half-width squared. And here, going to have z of 0.05 times 0.5 divided by 0.1 squared. And this value right here is 1.64. The value that we had here was 1.96. And we're going to have a smaller sample size requirement, 67.24. And again, we should round that up. So we 100% guarantee the half-width that we want, 0.1. So if you want to construct an upper confidence interval on the mu that has a half-width of 0.1, we need 68 students. That's at the bottom line.